Okay, Matt Roscoe at the University of Montana. Let's take a look at how we can use GeoGebra to carry out simple bivariate data exploration. So once we have our copy of GeoGebra up and running, we need to get the spreadsheet view open. And with the spreadsheet view, of course, then we can copy data, like we've seen another video, into that setting, and now we're set to go for some bivariate data exploration. So hypothetically, let's say that you noticed in this data set that it seems like the cars with the higher curb weights, the ones that are in the 5 to 6,000 or the high 4,000s, tend to have the lower fuel efficiencies. And so to explore that, what we might want to do is create a scatter plot of curb weight and fuel efficiency. So these two columns, columns D and columns F, we'd like to plot in a scatter plot setting. Now, since I kind of think of fuel efficiency as dependent on the weight of the car, what I'd like to see is curb weight as an X variable and the fuel efficiency as the Y variable. So let's go ahead and highlight the two columns. So the way that you get two non-contiguous columns to highlight is by holding the Control key down and clicking on the second one. So once again, I click on the F column, just regular old click, and then Control key held, click on the D column. Now I have the two columns that I would like to plot. So the way that you can plot a list of points is to create a list of points here under the drop-down menu for lists on the spreadsheet view. So I'll create a list of points. It asks me, okay, is this the way that you want the list to be constructed? 17,5357. No, I got it backwards actually. I'd like curb weight to be the X variable, fuel efficiency the Y. Well, the good news is all you have to do here is use this drop-down menu to switch the order of the tuple. And so there we have it. I'm going to give the list a name, curb weight CW dash fuel efficiency city, and go ahead and create that list of points. You can see the algebra view immediately shows you that this list of points has been created, as well as each point individually has been created. So now the question is, how can I get a view? If I click on white space in the graphics view, I get a whole nother set of tools which are associated with the graphics views, things like line drawers or perpendicular drawers or polygon drawers, circle drawers, angle measurers, reflections, translations, rotations, those are all in there, labeling tools. But one of the things you might notice is you get some moving tools here, like I can move around with that tool and keep grabbing and looking for these points, but the numbers are fairly large. It's going to take me a while to find them and search around for them, so it seems like an easier way to do this would just be to define the graphics window such that it includes all of the points. So the way that you can do that is by getting your pointer tool and right-clicking on white space in the graphics view and coming down here to the bottom of that, I guess, pop-up menu to look at the graphics parameters. Another place you can get to this is right here under let's see, view and layout, if you want to use that way of getting. Okay, so when you do this, you get to a screen that shows you basically the basic I guess elements of the graphics view are its dimensions axis and navigation bar and such, but the things we're really interested in are dimensions. So from the X direction, let's go ahead and start this at 0 and run it up to 6,000. In the Y direction, let's start it at 0 and run it up to, let's see, 48 is the highest fuel efficiency, the Prius, so maybe I'd run it up to 60 maybe, and just see what that gets me. And when I do that, it gives me a window where I see that all of these points now are visible. I can move this a little bit to give me some more space. And there's the points that have over here been defined. One of the things I notice right away is I don't like the fact that all of the points have a label attached to them, so we can tell, for instance, which one is which over here. I usually get rid of the labels, and so one way you can do that is you can edit any one of these objects in the graphics view by highlighting them, clicking on them. I used the pointer and drew a box around all of them so they're all brought up here. And then I can go to the object's properties. So you can do edit object properties right now. And it'll say, okay, what do you want to do with all of these points that we have highlighted? And the first thing I want to do is turn off their label. So I've turned off their label. Okay, nicely enough. But another thing that might be nice is I notice that this point and this point seem to be, I'm holding my control key down so I can get them both. Those 2 points, A and A1, seem to be points that are different than the rest in terms of following a trend. So it might be nice to draw the eye to those and give them a different color. So I'm going to make them red points. That's kind of nice. The last thing I probably want to do is I want to make all my points a little bit bigger. They seem kind of small. So I'm going to go to Style. Once I have all of them selected, bump up the point size a little bit. And so that's what I end up with my scatter plot so far. The other thing that'd be nice is to label the X and Y axes. The X axis in this case is, what is that? That's curve weight, right? So I'll call it curve. I'll just do a CW since it's understood. Somebody who knows the data set would know that that's curve weight. Okay, and you can see it's added that label down here. And then for the y-axis, I'm going to add the label FEC in miles per gallon. And you can see that the label is now added to that. Another thing that's sometimes nice to have is a grid. And that's up to you whether or not you like the grid or not. But I kind of like the grid, and you can just set the grid distance to be whatever distance you like. Right now it's default set to 10s here. It looks like 500s there. Or excuse me, set to 5s in the Y, but you can control that however you like. Well, once you have the picture you want, you're kind of done with the object properties arguments. And now it'd be nice to get a linear model that would fit this. Of course, we can use regression if we want, but for the 8th grade standard, regression's not included. In fact, that's reserved for high school. And so what we're going to do is just informally fit a line to this data. One of the things I noticed is I could pick 2 points, say that point right there, and I don't know, say that point right there, and use them to define a line that would model the data. Another way you could do it is simply to pick points out here and use them to define the line that would model the data. So that's what I'm going to do. I'm going to pick 2 new independent points outside of the data set. There they are. And then just adjust them until I feel like I have the right model. I can see right now my model is a little bit high, vertically shifted a little high because there are fewer points above the model than below the model. And so it probably would make sense to adjust this down just a little bit. And it's really a matter of taste at this point, since we just want kids to informally have a sense of a line fitting data. We're going to get some different answers from different kids, but the idea is not the right answer, but more the process of thinking about how a line could be fitted to the data. And I think that's a fairly decent fit. If I was really, I guess, particular about it, I might count how many points are above and below the data set, probably excluding those 2 just because I know that those 2 are outliers and are not fitting the general trend. Somewhere in that neighborhood I think would be a decent line. I'll go ahead and hide this point by right-clicking and showing object, and right-clicking and showing object on both of those. So that's my line. One of the nice things about GeoGebra is it tells you the equation of that line. Here it's in form AX plus BY equals C. But if you right-click and go to equation form MX plus B, you'll get this. And this is a little bit of a glitchy thing. And you notice that it seems like it's giving my y-intercept but no slope. And I believe the reason for that is because we have a very small slope here. And so what I think you want to do in this situation is you want to go to options and go to rounding. And I can see right now that GeoGebra is rounding to 2 decimal places. I'm going to go ahead and bump that up to 10 decimal places. Yes, now I can see what was going on. Hopefully you can see that the slope for this particular line was beyond 2 decimal point rounding. So I think I'll just go ahead and go back now and go to objects rounding. Oh, let's give it 5. There we go. So now I can see that fuel efficiency and curve weight are indeed negatively associated, and we could go ahead and try to interpret the slope here of negative 0.007 is indicating that, I guess, for every extra pound of curb weight, when we move this direction, we drop our fuel efficiency by about 7 thousandths of a mile per gallon. Another way to think of it is if we add 1,000 pounds to the car, we're going to lose about 7 miles per gallon. So probably an easier way to understand that slope. So that's one way that you can go ahead and conduct exploratory analysis using GeoGebra to get a sense of relationships in data.